Hello, everyone. Thank you for joining us for the newest episode of our Startup Spotlight series. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I would love to turn it over to our speakers for today. Thank you both so much for joining.
Awesome. All right, we are live. Um, thank you all for joining us for this session. Um, so today, I think each and every engineer kind of feels about it. Like it's the midnight. Your phone rings up and you see a midnight call, and then you realize it's the production issue. Your alerts are kind of spiking up. Your um, uh, pager duty is kind of ringing up, right? And for this, so today we are talking about how we are fixing these issues with respect to the SRE agent that we have built so far. Um, a quick intro about myself. I am a principal engineer working at Middleware, where we are building the agents, and we are kind of doing the heavy lifting of the work. Along with me, I have Vivek, who is the CTO of Microsoft Startups. He can give a quick intro about himself. Over to you, Vivek.
Hey all, I'm Vivek. I'm part of the Microsoft for Startups, and I work with middleware team to unblock them with any technology, technical issues and other things which they might require from a scaling perspective. I'm super excited to be here, Archesh. Thanks for inviting me for this session because way back in 2017 or 16, I had a privilege to build watchers with elastic watchers. Basically, watchers watch the log, and we build the auto redemption to that, and it's all manual, of course. And you did make a point, somebody working at 3 a.m. on these production issues. Yes, I have done that before in my DevOps role,
Mm.
and I'm sure most of the people who are joining in would have done that as well, and they want to see exactly what AI can do from a auto redemption perspective, solving the 3 a.m. problem for a lot of DevOps engineers, or you can call it SRE engineers and other stuff. I'm super excited, Achish, and by the way, for audience who have joined in, let us know from where you are joining in, because Archis and me are joining in from India, and you could just drop in the comments like from where you are joining in, and what do you know about auto redemption.
Awesome. That was a quite nice intro, and I think definitely, yeah, you mentioned correctly. Like it's 3 a.m. at midnight, and you're kind of figuring out like it's the production issue, and you're kind of going through the different tabs and the screens, and then you are unable to figure it out, like what's going into my code base. So that's the problem that we are looking up, right? You see you are like half asleep, and you see you squint your eyes and you see like your phone is ringing up, and you see a pager duty notification, and then you stumble upon to a laptop and open up the Slack, open up the uh, PagerDuty, open up the various playbooks that have been very much outdated, by some certain engineers who have written in the past. But then again, like you're kind of figuring it out, like what's going on with the error that has been throwing up. Example could be like your errors are kind of being popping up. It created the latency spike for the users, and it's kind of impacting where they could not um, see the API responses coming up quickly. So you go through each and every steps, like you kind of figure it out, like it took almost around 45 minutes of your time, and then still like you are unable to figure it out, like where is the issue that is going on. So six different tabs, context switching happening between the tabs, and then you figure it out, like you cannot find it where the code is going wrong. So to solve this problem, yeah, again, yeah, the PagerDuty itself, like there are various tools out there. And we did some survey out there, like almost like 60% of the time goes into just hunting. Like you cannot figure it out, like where the issue is going on. And once you figure it out, like most of the time has been spent, and then you see, oh, there was a small typo in the code, and you are like, oh man, like it could have been solved in within a minute, right? So this was the survey that we did. Like here, you are not able to figure it out, like where the things are going wrong. Almost like 1073 alerts got fired, like one CPU misconfiguration monitor or alert within the 7 days of span. The same resolution, there is a zero resolution like this. It's kind of bumping up into my observability platform, but I'm not able to figure it out where the things are going. And there are like bunch of P1 tools like PagerDuty, Datadog, Loki, etc. These tools basically tell you that there is an alert. But in today's modern world, we need a solution where and AI could take an step further, and even when you are asleep, it takes an action behind the scenes and goes into the downstreams of the systems and figure it out where the things are going wrong, and take an action and give you kind of a PR to it. So that's a very happy resolution case where we see pull request to the developers, and every SRE engineer within a seconds would be happy enough to get it done. Here's one of the case that we came through, in today's world, like you see, like writing a code is been much more simpler. Like you tell your Copilot, or you tell your Claude, or a Chat GPT, or Cursor, like uh, it's been way much more faster than what is the prior to the AI. You simply write test cases, reviews get passed, your dev. I mean, today, I mean, AI reviews have been also in the picture, so they take care, and with the simply CI/CD pipeline gets passed, and then you see a simple, nice green button, and developer hits that merge button. Once the merge button is hit, your code goes into the production, and you sleep at night, and suddenly at 3 a.m. you see like an edge case got missed, and something is breaking in the production. So today, if that issue happens, engineer has to wake up at night and has to go through and debug the code and see like where the things are going wrong.
So before you go
Yeah.
into next, so I have a couple of questions here. So it's not a question; it's basically, what I have seen in
Mhm.
past, right? So I've been in DevOps head, and we have done all of these things at 3 a.m. or 2 a.m. There is production has gone wrong, and we debug logs. We've seen this, and uh, and obviously it takes time to figure it out. And
Right.
I mean, we used to do all of these things at whenever there is a production is broken. It has AI coding made it worse, or is it has got better, and these kind of tools actually really help in terms of solving that. And I'm curious to know, obviously you don't have to answer it right away, but I'm curious to know what's next. Now how exactly it has solved the problem for DevOps engineers like me, you know
Yeah.
go ahead, Artish.
I think, yeah, I think you'll definitely get answers in the upcoming talk that we are going to do. But yeah, I think that's an interesting point, like how AI is kind of changing the world in terms of not only writing the code but also debugging stuff, like thinking like like an engineer and going down, like drilling down and figuring out like where the things are going bad, and then taking a control over it and making sure that things are absolutely fine. So let's move ahead. Uh, so again, talking to this, like the traditional systems, like the observability platforms that we had, uh, again, like they used to collect the data from the various systems, like maybe like an APM system, or maybe infrastructure. All this data gets collected at one place, and still today in observability platforms, we kind of go check the correlation. It could take an hour to kind of figure it out, like where the things are going wrong. Kind of hits a productivity for the developers. So I think over the time, the decade, the observability system tells you that something is wrong in the system. But today that we have built so far, it actually tells you and also fixes along with it, how it's been done throughout the software development lifecycle. So, so we built the opsAI, which basically it's an AI SRE agent that lives inside the middleware. It knows like what's your stack is. It knows what's your services are running. Like it could be Python, Go, Node.js. Like take any of your favorite languages that you have been uh, having a tech stack behind the scenes. Just do kind of observability integration. It kinds of watches throughout all of your services, finds the root cause, like where the things are going wrong, and eventually gives you a handy PR to you. That's very much simple. Like you don't have to run brain like where the things are going wrong. I have a PR. I just have to deploy that PR into the production. And for also like we also do the Kubernetes change. Like for example, a pod is kind of crashing over the time. Um, like our SRE agent can take a control and kind of do the real world fixing into the um, Kubernetes cluster itself. So again, like there are four basically steps that we do. That is like detecting from whether it's from APM, whether it's a RUM. RUM is basically a front-end observability along with a K8s cluster. There are a bunch of logs, metrics, traces. Along with once it detects the issue, it basically does the diagnose. I mean, like it kind of does the complete RCA of the error that has been kicked in with a RASI framework, where it tells you like what impact it created, like what action that you can take, what can you see like metrics, what are the traces during that time. It gives you the detailed report about your error that has been occurred, and then it gives you the simple handy PR at the end, like looking at this data that it has collected. It has context built behind the scenes and directly gives you the GitHub PR or a GitLab PR, bunch of integrations that we have, but it gives you handy PR to the developer within, I would say, in a short span of time. And along with there are like uh, data getting ingested from various third-party observability systems, whether it's Datadog and Grafana. So these kinds of alerts that gets uh, ingested inside the middleware platform itself. So the app opsAI can take a control and give the detailed analysis of it.
So Artish, I have a, I'm trying to understand this correctly. So basically,
Mm.
inside middleware, um, all these logs and other things gets collected, and then your agent runs on top of this and sees the issue, and then it opens a real PR in GitHub, and
Correct.
then it auto writes the code and fix it. Uh,
Correct.
is that my
Awesome.
understanding
Yeah.
is correct?
Yeah. I think.
And it
Yeah.
you
Correct.
support all different kinds of tooling for this, like Datadog, Grafana, bunch of APM tools, and also also the logging systems, the Prometheus and everything, right? So
Yeah,
you support all kinds of tooling for that to bring in the data into the middleware and then run your agent to uh, get this get the issue fixed through GitHub
correct.
PR. Correct?
Correct. So yeah,
Okay,
so the data
perfect.
can
Yeah,
be, just by adding it, the data can be in the different forms, which are kind of residing into your third-party observability systems. Our middleware kinds of pull that data inside the um, middleware dashboard, and then you can run the SRE agent on top of it. So that's the stuff we do.
perfect.
Yeah, again, like now as these what kind of errors that we collect, it could be um, like runtime exceptions that have been like a backend crash happening in your Python code or a Node code or a Go or a Java or Next.js. Example could be like an undefined exception that caused in my code, and that is kind of ingested through APM, along with like Kubernetes events, like example could be like an OM kill, like out of memory pod got died, like certain daemon sets do not get certain memory or something like that. Any pod related events or any Kubernetes events that occur over the time, uh, that data gets also collected along with the front end observability. Like there's a very common use case where users are trying to click on a button. A developer wrote a code, but now that button is kind of not working because it missed the edge case of undefined, and it will kind of throw the console errors. So the data, our agent SDK can kind of collects the console errors from um, the browser, along with any network errors. Like if you are making an API call and it results 500, it's kind of internal server. It also captures like why the API cost the AP 500, along with any user journeys that are along the way breaking through in the front end observability part. Uh, the
This
next
is
is
this
basic.
is inter- this is
Yeah,
interesting because I mean, at the time of where I was building watches and with Elastic and for building those auto redemption things, right? Basically, the we could only do some exceptions and that's it. I don't think so. We could have gone to browsers and getting into Grafana's, Datadog and other things because we were just looking into the logs which we were getting into the Elastic. That's an interesting thing which I see here is the browser side crash, right? From a as a developer, as a DevOps person myself, there is, I mean, obviously backend issues, you get it, but then there is a client side error which you are also pulling into your middleware, which is really cool to see.
right. Yeah, and certain times like also that also creates an impact. Like for example, you're clicking on a button, but behind the scenes, like that is making an API call, and that API call is heavy, which eventually leads to CPU and memory spike behind the scenes. You also want to have end-to-end traceability of your stack behind the scenes, what's happening,
Correct.
right? In certain cases, if you kind of capture only the first part of only the browser side errors and you skip the backend errors, you will be not able to get end-to-end traceability. And at certain times, it's very much important to kind of observe your system, and you know your system best, right? So uh, adding more metadata, like it can be like open telemetry native SDK that you have integrated. But again, like we are kind of heavily on top of the open telemetry native. So our SDK itself are capable of collecting this traces, the events, and the browser side errors from our SDK and kind of showing it into the middleware dashboard.
Perfect.
And the fourth interesting part that we talked about, that alerts. It's a very important part. Like you know the data has been kind of present in your observability system, but it's also important to set up some alerts that we saw. One of my engineer kind of depict about the read method and the use method, like how to set up the alerts in terms of in the observability platform. That those are very much important metrics that you need to set it for the observability platform. And these alerts can be in middleware platform as well, but in the third party platforms as well, like Datadog and Grafana. And these alerts are directly ingested into the middleware platform. You just have to kind of do some a bunch of integration, just set up the API keys of Datadog and Grafana. Uh, there you go. The data gets ingested into the middleware. So overall, if you look like it's kind of a one roof where every every layer is kind of built on top of it, and each layer will have its own kind of a flavor to kind of cater to different developers. It could be a front end engineer, it could be a back end engineer, or a DevOps engineer altogether. And you can think like opsAI, who kinds of it's kind of a on-call engineer who doesn't do context switch a lot. Like I mean, like it knows like what to do, where to go, which logs to check, which traces to check, which metrics to check. And obviously it doesn't sleep. It doesn't forget about running the playbook. Knows each and every services. Like along the services, if there are any load balancers or any backend code that has been integrated. And the interesting part about this is like it knows like which code to read as well. Like it doesn't go blindly read your complete repository, but also understands like if there is a code that needs to be fixed and write a fix on top of it. Also, it asks about the review as well. Like, do you think like you can ask those questions to AI as well? Like, do you think like this diff that I've given it's correct or not? You can tell the AI to kind of mix and match with respect to the code that AI has given. Similarly, if again like in Kubernetes, it's straightforward. Like it has figured out the issue. Now it has to kind of do a config change itself. It will you just have to simply tell it, or if you have done the automations as enabled as well, it will directly go into your cluster and kind of do that changes for you. Awesome. So now you see like how the AI kinds of do it. So there are 5 important pillars of opsAI, from incident to the fix. Initially, it detects there if there are any issues across the APM, KTS, RAM, or alerts, or any third-party signals. It does the detection part. Once you have the detection part, it builds the context. It does the root cause analysis of the complete end-to-end, where our agent knows like which traces, which logs, which metrics, and if there are any recent commits that have happened between the course of the time. Uh, and then it kinds of take the resolution phase, where it kinds of look into the stack trace that have been captured, and it kinds of look like which kind of code is breaking. It traces back to the original PR or any past changes that have been occurred in the in your repo. Along with it kinds of correlates with any of the traces or logs or metrics that have been equivalent with respect to the code that is failing. And very simple, the last step, it kinds of uses the uh, uh, GitHub MCP to kind of generate the pull request and hands you the diff, and RCA to kind of engineer like where an engineer can chip in and generally merge that PR. Once this step is done till step 4. In step 5, you can give feedback to the AI, where we take that feedback and see like how does the opsAI perform throughout the time. And this all things happen under 3 minutes. Like you are just like going and having a picking up a coffee. Meanwhile, your kind of issue has been resolved in the meantime.
So Archish, there might be students who would be watching this, session. So, for their benefit, can you explain the MCP which you talked about with GitHub MCP, which you talked about? How does it work? And what is MCP, and then how does it work?
Yeah, I think it was interesting use case that was built by the Anthropic company, and they know like nowadays like each and every company or each and every a developer is kind of making their own kind of AI, and like to communicate between them, there is a common protocol that is called Model Context Protocol, where basically the context of what the AI is doing gets transferred over the network, and then they kind of communicate it to them. So I can write like my opsAI can do certain tools like kind of querying to logs, querying to traces, querying to metrics, along with like it could like stop the automation, start the automation. So these are certain set of tools that is part of my opsAI. But what if like I have another agent who wants to call my opsAI agent, right? So we need a communication between them. So that's where the MCP comes into the picture, where the other user, I mean the opsAI will write its own MCP server, and like users can kind of call our MCP server and call this certain set of tools that have been exposed, so that it also does the agent to agent communication as well. And along with the humans in loop can also make use of tools and get data from with the help of AI can get data from middleware. So that's about like how does the MCP fits in the ecosystem of the AI.
Yeah, so basically the ops AI agent, if it wants to talk to GitHub agent, it requires a protocol to talk to each, and that's
Correct.
protocol is MCP. Perfect.
MCP. Correct.
Let's move on.
This is the bet that we have taken so far. Like where opsAI agent it sits directly on top of the observability platform, where it knows everything, like it does the reasoning and the action part. And as you can see, as you go drill down, where you see a GitHub MCP server, where it goes through the code, like stack traces, figure it out what's the nearby code along with the stack traces, and obviously it's only in the read-only mode. Like the data completely resides on the GitHub itself. Like it's nothing comes to like nothing is stored on the middleware platform. It's completely on whatever it's there on the Git using the GitHub MCP. That like it kinds of scan through the code, looking like which relevant files are there, what files to look upon. So with the help of GitHub MCP, we leverage that, and be under the hood, like middleware unified platform, like completely observability platform that sits in like where you can do APM, RAM, Kubernetes, logs, metrics, alerts, and the bottom it's the data getting ingested from the Datadog and Grafana. So now if you look, right, you might ask a question like why like AI agent is basically sitting and it's kind of like only the middleware data can be accessed. Think in other way, like there are other companies as well, like they are kind of pulling the data from the various sources. The common, let's say, common engineering problem where it can give the latency, it can do rate limits, schema mismatch, like bunch of like plug and play things, and eventually like you will see like the AI is getting slower and slower to give the responses. And during that time, you at peak hours, you need an agent which is kind of a super fast and could deliver you in within 2 to 3 minutes. And similarly, we did bunch of testing with respect to the other AIs, like Resolve AI is one of the prominent player which kinds of pull from the various systems. But if you compare, we did a quite benchmark on top of it, and we see like having an agent sitting inside the observability platform performs way much more faster and better in comparatively in issue resolution. It's kind of like and it's your own car where you're taking different passengers together and getting your stuff done in a seamless manner.
What about the lock-in here?
Um, can you highlight?
What about the lock-in things here? Basically, in this architecture, um, there
Correct.
is a couple of
Yeah.
things
So
which is logged in to middleware, right? So, how does it work for uh, our enterprise? Who is always worried about lock-ins and bunch of other things, about using a platform. So, how do you guys deal with this in terms of lock-in? And I am sure you would be getting these questions from
correct.
enterprises. So, what will be your response to them?
Yeah, I think the interesting part, like lock-ins, it actually means in that way, like your data itself resides within the single platform. Like you don't have to kind of juggle between the two different platforms, or as you can see, the agent, the middleware platform itself, it's in the center part itself of the it's a core part of the observability system, and the agent sits on top of it. So the data itself remains at one place. It doesn't move out from the uh, other other clusters or other regions. And over there, the like you can run the um, like fixing of the issues on the single platform itself. So that's what we mean. Like your data is locked in with yourself only. Like it doesn't goes beyond the scope of any third party providers. So that's what we meant.
Perfect.
Again, like this is the interesting part. Like now we see obviously like giving something to AI in the production, it's kind of a big question, right? Should we even give it? No, because it can do a bunch of different things and we don't know what's going on. There was the one analogy like the AI was given a control to the database and it kind of deleted the whole database. And that's kind of a chaos, right? So again, like opsAI operates within the boundaries that you define. It suggests the solutions, generates the PR based on your context, and applies fixes only if you have granted the permission to opsAI. So in terms of Kubernetes, like you can uh, give the certain controls for like read and write, something like that, and it can kind of run only those sort of commands in the production clusters as well. And like for example, like the other case is like um, like it does the investigation, and you don't have to trigger. Like it is like just a one switch on. It kind of does the auto investigation like without even you actually hitting the fix button or something like that, right? uh, but again, that control is in your hands as well. If you don't want auto investigation, you can simply turn it off. And similarly, like um, token control as well. Like you can like kind of do token limitations as well on your end. If you see like uh, opsAI kind of using tokens, you can kind of add an alerts on top of it saying that only this much number of tokens has been used, so that in terms of pricing also you don't spend too much tokens, but you can have a control on top of it as well. Yeah.
So, one question here, Rajesh. So, basically, um, if um, if I have to fix only certain kind of errors, can I define it? Like I don't want it to fix couple of errors, maybe the complete production down. I just want to know what happened. Probably want to go there, but there are some kind of errors which maybe through microservices or a couple of services down. maybe some crons which I'm running, those kind of things are down and want to fix those kind of things. So is there a way to choose between different kinds of issues uh, to go
Right.
and fix it?
Yeah, I think that's a very interesting point. Like you don't want to do AI investigation for all of your services. So what we have built, we have given a setting control where you can select which of the services. As of now, we have on the service level, you can pick and choose like which service you want to run the AI investigation. And opsAI will then take over the complete control. Like for example, I have my front end app called my demo production app, and I just want to run the opsAI on that. And there are like bunch of other applications that I've been observing in the middleware platform. But however, I just want on that. You can select that app, and opsAI will only run for that services. But I think this is an interesting use case that we can definitely look through it if we want to run for a specific errors or specific things. But at overall on high level, we have a control over at your service level. So that's
Perfect.
the so again like so all this uh, stuff like which opsAI does. So uh, there's one more thing which questions come to mind. Like, does it read all of my code? The answer is simply no. Uh, when the stack trace is received at middleware, like we generally kind of do the correlation part heavily. Like we kind of check like what are the relevant files that's kind of touching through it. Um, Not your complete repo, not the directory next door. For example, like a root directly, and it kind of scan the whole code. No, that doesn't happen. Only the reference files that have been through along with your stack traces, it checks through that. Uh, you also get then access to a model MC protocol where you can kind of pull a plug tomorrow. Like let's say you don't want a GitHub to be integrated with middleware, you just kind of pull that plug. We don't want it, right? So you can have a like a switch that is under your control, and whatever the source code that's in your repo stays within the GitHub itself. We do not kind of pull that source code into our middleware platform. However, we make use of GitHub MCP to kind of scan through your code and get the relevant context out of it, and give you the results out of it. The important part over to know, like we are compliant with SOC 2, Type 2, with ISO 2000, 2701, with GDPR and the HIPAA compliant as well. So your data is safe. Don't have to worry. Just kind of go there and kind of get the hands on. I think we did a good amount of talking where we figured out like many things like how do we do it. Now let's jump deep diving into the real things. How does the opsAI comes into the action and does the stuff? So initially what we are going to do is let's take an example where your a backend service is kind of throwing an error, and how we can solve it the middleware opsAI. So this is the initial screen of the opsAI where you see like bunch of errors that have been in your screen. And as you can see, like I've generated the real world errors that have been popping through my application. So this is the listing where you see all of the errors that have been coming from my Python app. It's a type error within it's a 14 minutes ago that has been caused through. I just simply click it and kind of look at this error. Like it's kind of errors that has been thrown through. As you can see, like it's kind of a type error that has been raised due to like my order listing did not return a valid response. So in this case, like I simply go and kind of uh, confirm like this is my repo for this, and I do look for fix. Now, the agent, as we talked about, like what it has to do, like it has to do the RCA, like it has to go correlate with the traces, correlate with the metrics, correlate with the logs, any events that have been occurred throughout the time, and figure it out like why this error kind of popped up and what was the actual root cause that lead to this problem. So it takes around like 1 or 2 minutes kind of figuring out like what's the context about, where it's the uh, where's the code actually residing, also going through the GitHub MCP to kind of check like which line or which code which is relevant to this stack trace. So meanwhile, it's kind of deciphering, like we can go a little bit of the other views. Like there are like as you can see on the bottom panel, it's completely like what are the attributes that has been collected like with respect to the um, PR, like it could be the Python or it could be like what's the host name, if there are relevant IPs, what's the process command, what's the PID, like bunch of informations that has been collected through. If there are any relevant logs to it, currently there are no logs. So it gives you the complete view of it. Similarly, like there are infos like GitHub URL, what is the tags of it, with like which URL it's coming from, what's the agent that is coming from. So that's all like bunch of basic information from the observability platform that we collect through our SDKs and we show it in the bottom panel. As you can see, like behind the scene, like it has made the plan. Now it's kind of going through the logs, metrics, and traces, and figuring out like where the things are going wrong. And it will, as you can, and we can see like it has handed over me uh, a nice a nice little a graph, like saying that this was the trace that have been that was kind of uh, it's inside the middleware APM, and it's kind of going through it. Just give a minute or so, so it will kind of do other bunch of stuff. Yeah. So meanwhile, it's doing like we can also check like what other things can we do behind the scenes. It will the AI will do its work. There is also the option which talks with opsAI. Like let's say you are observing any spikes or errors over the past 30 minutes. You can simply like a kind of there are a bunch of stuff that you can ask to an AI, and when you hit this button, the AI will kind of go into deep down into the systems in past 30 minutes, like what things have been going wrong inside the observability platform, specifically with respect to my app. It will kind of collect that data, will show you the uh, bunch of informations like what is the graph looking like, why it is spiking through it. And again, like it's going and analyzing the cluster as well, and everything is async, right? You just have like AI engineer has to just click on buttons, and behind the scenes it will be doing. So let it do behind the scenes. Meanwhile, we check into the uh, code. Amazing. I think it kind of searched the order listing from the repository. What has been changed, like any Flask, like this was the code line that it suggested. Like as a developer, like you can actually have like view a split view or a unified view based on your needs. And it explains like why this change, what impacts it create, like uh, any suggested test cases that has been that you can add with respect to this code. And simply like at the end, it gives you the like a root cause analysis, what has been throwing through it. It also hands you that traces with respect to that. And finally, like what was the before fix and the after fix? What's the impact of it? This is basically following a RASI framework where you can like understand the actual root cause analysis, and then you can like do the bunch of tests, or you can add tests. Now, let's say I want to apply a fix. Simply, it will kind of make use of GitHub MCP, create the um, like do the commit, simple like git commit, give your commit messages, and then get pushed to your specific branch. So it will create a dummy branch onto your platform, and it will give me the pull request. Quite easy for me. Like I don't have to like do like juggling between the tabs, context switching, like everything. The agent is kind of taking a control and giving me the pull request. So it takes a couple of a minute or so to kind of pull the request. Amazing. It did quite fast. So it, yeah, go ahead. You have a question?
Yeah, actually, I have a question. I mean, it's kind of interesting and the question as well. So, um, interesting part. I don't know, audience noticed this because it didn't just patch the symptom. It basically, if the error, right? It went ahead and fixed the problem. Actually, it didn't just one time fix. It did not do a one time fix, but it actually went ahead and actually fixed the code which was causing the problem. And my question to you is whether this is something which you train the ops AI ops for, or I'm sorry, I'm getting the name right. What is the
Yeah,
name right?
opsAI,
It's the
opsAI.
ops AI. Okay,
Right.
ops AI, or is it something it is learning by itself to fix it?
Yeah, this is our AI like understands like again as I told like collects the uh, data from the various system, pulls from the middleware platform. It generates the context, and currently we use behind the scenes like various LLM models, and we feed those context to our LLM models. All of the LLM models that we use are kind of all of the latest models, and we use bunch of different mix and match LLM models. Like for summarizing, we use different LLM model. For logical reasoning, we use different LLM models. Similarly, like for uh, graphs and other stuff, like we use another LLM model. So we build the context, we give the all of the relevant information, and we feed it to the AI, and then AI basically does all of this stuff because it has the data collection. Like we as in middleware platform know where the data resides, right? So we kind of generate all of the possible context and we feed it to the AI. Now the AI is smart enough to take a control of your of the context that we have given. It understands those contracts context and gives us the final result on top of it. uh, the other bunch of stuff like applying the fix, again, like we give the stack traces, we give the specific uh, commands like git commit and that sort of thing. Like like behind the scenes with the help of GitHub MCP, we kind of trigger the creation of the PRs and like there you go. I think that's the final step. That's the final step
So
that we do.
one question I have is, as a DevOps engineer, right? So I was head of DevOps. So basically, I have this question for you: is basically, uh, does it do a code review? Like, is there any other AI actually reviewing this code uh, when you push this PR automatically?
I think, yeah, definitely. I mean, right now, we have given the control to human as well. But before even leaving things from the middleware, like generate before even PR getting generated, like as you can see, you can tell them to add a test case. You can
Perfect.
tell it's like an AI for you. Like you just have to tell AI like to kind of do the add more test cases. Like there is a bug I see in this particular code. Can you basically help me through it, or can you make refactor in a different way or something like that, right? Everything that you, it's kind of a AI that's in your hands, and you can kind of uh, do bunch of additional steps that you want to do on top of it. So
Perfect.
again, like AI reviews can also be done. Just you can just tell that can you review my code, or can you kind of do bunch of variable changes, or write a clean code for me. that can also do for you.
Perfect.
Awesome. And finally, like when we see, like we did a chat with respect to in the demo, it gives me a lot of context. Now you see, right, like to build this context for an engineer, like within at 3 a.m., it's kind of hard. It has to, like, you, the developer needs to be in god mode to kind of figure it out where the things are wrong in the production. But again, this is what the AI does, like it knows where the things are, right, and kinds of give you end-to-end traceability. Like as you can see, in last 30 minutes the payment service was om killed due to memory was less. There was total five restarts. There was again the another root cause that can see the tutorial service was around 2560 error logs that have been occurred. Similarly, that there are more restarts gives you all of the services, like why it's kind of in past 30 minutes. Uh, mm, there were spike of errors. What all those errors are, it kinds of summarizes you, and like you can kind of again, you can apply a fix from here as well, like patch payment service altogether, right? It could directly go and apply a patch to the um, code itself. So that's about APM. I'll also jump into a little bit more on the third-party alerts, as in like we talked about, like data getting ingested from Datadog or Grafana. We also have like I've triggered that alert, which behind the scenes same stuff like we did. The alert was from this alert is specifically occurring at the Datadog platform. We kind of pull that data into middleware, and with the help of opsAI, you tell opsAI to kind of look for fix. It kind of like went ahead the cluster, kind of looked into the demo cluster, like what are the CPU kernel metrics look like, gives you the like what are the next steps that you can take through it. Again, like this is the data getting ingested from the third party. If we have control to that K-test cluster, we can also kind of do the directly code, like applying the patch to the K-test cluster. But again, like if not there, you can like ask more questions with respect to the errors that has been popping up. With same with respect to Grafana as well, with same respect to the Datadog. The
Perfect.
next part,
So,
yeah,
so
yes.
how many services do you support? Grafana, Datadog, and what else?
Yeah, I think right now we support Grafana and Datadog, but eventually our plan is to kind of support more integrations, so that like people can pull, if they're using any other observability platforms, you can pull that alerts into middleware and you can leverage the power of opsAI completely.
Perfect. So even before we go into next set of things, Arches, I think we need to let the audience ask a couple of questions as well,
Sure.
because we are like 5 minutes, 5 to 8 minutes we have, so we can give
Definitely.
some time to audience to ask questions. Uh, so we are waiting for audience to ask questions here. While you ask questions, I would like to say, Arches, this is an amazing platform, and uh, I mean, I'm super impressed in terms of how it can go and fix the problem, and not just fix, doing a small fix and timely fix. Instead, it going beyond and then fixing the problem itself. And it's the best time to be a DevOps engineer,
Yeah.
because of the AI and other things which is out there,
Yeah,
right?
we are trying
Um,
to make easy life for DevOps engineer. Obviously, like companies like Anthropic and the other AI companies have made easy for engineers. We are kind of helping the DevOps engineers as well to make their life easy and super quick. So
while we are waiting for the questions to come in, you can actually show what you wanted to even demo further.
yeah, so the other demo that we are going to do is on the opsAI like K-test part, where I think it can do for like OM kill. No, I think we don't have it. Mm. No, we don't have any OM in past 2 days. That's okay. All right. Uh, so let's take an example of this cube agent, right? Or maybe take an example of this recommendation service. Uh, we simply go and hit the look for fix. It will kind of again do the RCA, and just like we did like apply a fix in terms of code, it handed me the PR. But here the things are different. When you say apply a fix, it will directly go into the pod and kind of apply those OM patches directly to the K-test cluster itself. So next time this error won't be popping up, it will kind of upgrade the uh, cluster and make a proper fix to the uh, error so that it doesn't pop up again. So meanwhile it's doing, I want to show on the settings part that we have in opsAI, like as you can see, like one interesting question, Vivek, you asked about in the talk, like what if I want to give a control to a specific applications, right? You can like select as of now, like as the auto investigated button is off, it's kind of in your control, right? The DevOps engineer has that control whether to turn it or turn off. Once I turn this on, example, I can select like which all services that I want to do. So these are my bunch of services. I just only want to do for uh, like um, like for example, I want to skip for other. I want to just do for this particular services, right? So it will kind of investigate opsAI only on this particular services. The other services, opsAI will not kind of look into it. And what notifications once let's the resolution happens, you can select like which whom you want to send that notification, right? Once the resolution is done, you can do Gmail, you can do Slack, Teams, or any webhooks that you have integrated. Um, Similarly, like again, this is auto investigated, which means like when the error gets triggered from your platform, our opsAI will go to that error and kind of give you the complete end-to-end resolution without even an engineer being in the loop altogether. So let's take an example at 3 a.m. Some error pops up and auto investigate is on. Just think like within 2 to 3 minutes, an AI and like a DevOps engineer gets a handy PR. Even that PR is not merged yet, but it will give you the PR end to end. And finally you just have to review that within like 2 to 3 minutes and just merge into the production. So the complete 45 minutes of your time, it's kind of shortened to within 4 to 5 minutes, and that's it. Your code goes into the production, things are fine, you go back to sleep again.
Yeah,
Hmm.
that's interesting.
Cool.
Actually, yes. I mean, that time reduction is definitely impressive, right? So, so audience, if you have any questions, just share it. But like me, Sanjay, I am pronouncing the name right. Like Sanjay said, he's impressed with the app.
Yeah.
So, thank you, Sanjay, for that comment.
Uh, and finally, we jump into our closing steps. Like these are the real numbers that we are talking about. Like it has almost solved 50% of the middleware's own production issues. Like we itself are kind of observing our own platform, right? It's like chicken and egg problem. Who came first, right? So like we are solving our own issues. So we are seeing like bunch of like developer productivity that's around more than 50%, like detection of the 70% of your across the customer beta accounts that has been kind of opsAI taking the control and kind of giving the fix. Again, like MTTR reduction, it's around 5x. That's a very good number in terms of industry if you look right. And secondly, like fix accuracy is 75%. It will kind of give you the better results within the auto investigation. But however, again, you can improve that accuracy by talking more to our opsAI. like overall, like the you can see the AI remediation distribution, like KTS autofix has been the maximum part that has been playing a vital role, where it kinds of does the patches directly to our cluster, and it's kind of giving a good results, and we are seeing the uh, better improvisation in the SRE engineering. So again, like we see like one of our customers who has been uh, seeing that around 90% drop in the debugging time, where and it's kind of head to head against like competing with the other agents that are in the market, and like opsAI runs almost like 6 to 10x faster the identical prompts with respect to the other AI platforms that are being live into the market. Um, we did a good benchmark numbers with respect to the other AISR agents, but however, like opsAI is kind of quite faster in terms of giving the same results as well. I'll kind of let you read through this. This is like we are solving this for um, our or the insurance company, which kind of seeing the reduction in the debugging time and resolving the issues nearly by 90%. Like all of their issues are kind of going through the auto investigation part, where AI itself is kind of correlating, getting those results, giving those RCAs within like 2 to 3 minutes. Feel free to chime in if you have any questions or doubts. Like like if anything goes wrong, or if our opsai is kind of not able to do it, like we have community like where you can talk through it, can give bunch of suggestions that we can kind of take into action and kind of do improvements into our product. Definitely we love your feedback, and we want to improve our platform as better as it.
Yep. So if I'm watching this session, right? So uh, two things you should be doing if you guys are watching this. One is basically book a demo with middleware. There is a link in the chat where you can go back and book a demo and see. Not just this, there are a bunch of other things which they do. I think you should uh, book this demo and take a look at a lot of things which is there in the platform. And if you want to know more, whatever we have discussed, there is a link for that as well, which is part of their opsAI. I request you to also go and check it out, and then book a demo. And I think uh, that way you will learn a lot about AI stuff, fixing the production issues and other stuff. Before we, you know, close this session, is there any questions from audience? Or else I was the only one who was asking questions. So I don't want to be that person. So if there is any one, we can take one question or two questions, you know.
Oh, I think we have a question from Durgesh, if I'm not wrong. Um, is there any documentation or article published for this? Yes, we do have it. Um, I think it's on the product slash opsai, where you can read it through, like what it does in terms of fixing those errors, like the talk that we did. Similarly, we'll find more insights about in depth about how opsai behind the scenes it does the resolution of the RCS, uh, going into our like in depth about our uh, opsai platform. So just kind of give it a shot and see like how does it help you through it. So,
Perfect. Perfect. Cool. We're good to go. Thank you,
awesome.
folks. Thank you for joining in. Thank you, Archesh. This was really good and I enjoyed it.
Amazing.
See ya.
Amazing. Cheers, for have a great day.
Thank you all for joining, and thanks again to our speakers. This session is part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.